save. Yes, sir. All right. We are going through चल भाई अपन एकदम फास्ट फास्ट करेंगे फालतू टाइम नहीं पास करेंगे. We are going through these experiments, create a list of phenomena that we need to be really aware of and good at to execute these correctly. Curate a list so that we can start researching on it and know about all the key metrics here and make sense of it. Okay, ये देख भाई. Let's take advantage of YouTube.
In the last couple of videos, we saw that convolutional neural networks create features to represent parts of images, and then later combine those features together to understand larger and larger parts of the image. However, we also saw that if the network is supposed to process a 1000 by 1000 image, it needs 500 layers. With that many layers, there could be problems with diminishing gradients, where the network is simply unable to learn what the proper weights are in the beginning of the network because there are just way too many layers. Also, even though convolutional filters are fast and use few weights, with that many layers there could be problems with memory or execution time as well. How do we reduce the number of layers needed in convolutional neural networks? One way is pooling. Pooling is a method to dramatically reduce the size of the intermediate features. If we reduce the size of the intermediate features, then we need less layers in order to cover the whole input or to reduce the input down to something more manageable. Similar to convolution, pooling takes a filter and slides the filter along the input according to its stride. Unlike convolutional layers, pooling doesn't have weights, and instead computes some operation on each valid position and returns a single value as output. Two common operations are max and average. So if you have a 4x4 matrix with a 2x2 filter size with a stride of 2 and max pooling, all you are doing is looking at each 2x2 block in the input and getting the maximum value. Looking at the first block, the highest number is 5. The next block, the highest number is 12. And so on until you get the final output. Pooling like above reduces the size of the intermediate features by a factor of 2 every time you do it. Typically, you alternate convolutions and pooling layers until the intermediate features have a size around 1 by 1. Given a 1000 by 1000 image, you could reduce the internet feature size to 1 by 1 in the following manner. Starting with a convolution, and then a pool, and then a convolution, then a pool, then a convolution, and a pool, and so on, all the way until it becomes the size. Then that gets fed into a fully connected layer to make sure the output is the right size, and you add a little bit of non-linearity, but that's not relevant here. now, instead of 500 convolutional layers, it's only 17 total layers, including all the convolutions, pooling, and the fully connected layer at the end. If you just count convolutions, it's only 8 layers. Pooling is used in the real world after convolutional layers as a way of downsampling. That is, it is used in order to reduce the size of intermediate features and therefore the number of layers necessary. It's used in basically every task where convolutions are used, including image and text classification.
भाई तेरे को समझ आया वो फेलियर क्यों हो रहा था अब? अरे
क्या
भड़वे, तू देख नहीं रहा था क्या?
देखा मैंने, बट मुझे आवाज नहीं आ रही थी। मुझे वो तो समझ आ गया था कि वो कन्वोल्यूशन न्यूरल नेटवर्क से करवा रहा है वो,
अरे तो बोलता ना तेरे को आवाज नहीं आ रही है।
बट मुझे समझ आ रहा था थोड़ा बहुत कि वो क्या है।
वो बता रहा था कि पूलिंग बेसिकली होती क्या है, तो ये देख।
वो तो मुझे पता है पूलिंग क्या होती है, मैंने सीएनएन पढ़ा है भाई।
अरे तो अच्छा, तेरे को वो एरर समझ नहीं आ रहा था तो
हाँ,
फिर?
मुझे आ गई थी समझ में, वो तो मैं तेरे को समझा रहा था भाई, वो तो मुझे एक लाइन में समझ आ गई थी एरर, कि वो क्या एरर हो रही है।
हो गया।
वो तो मैं तेरे को समझा रहा था भाई, मैंने तो सीएनएन पढ़ा हुआ है, तो वो मुझे मालूम है कि वो कैसे मैक्स पूलिंग करता है, वो
हम्म।
फंक्शन कैसे काम करता है, वो उसके आसपास के एरिया को एक उसमें कन्वर्ट करता है और फिर वो यूज
हाँ
करते आता है, वो मुझे पता है भाई,
तो
वो
बेसिकली
फंडामेंटल टाइप से पूलिंग एग्जिस्ट करती है।
वो जो फेलियर वाला वो था इधर, तो जैसे यहाँ पे अगर ये फेलियर वाला ब्लॉक रहा होगा और बाकी सक्सेस वाले रहे होंगे, तो ये सक्सेस वाला
So,
ब्लॉक
as outliners,
क्रिएट हो जा रहा होगा
two common
उसमें,
operations
तो
are
वो
max
फेलियर वो
pooling and
डिटेक्ट नहीं कर
subtracting.
पा रहा है इसके
हाँ,
कारण।
We
क्योंकि
have
वो
a
रेंज
4 by
बहुत
4
ब्रॉड हो
matrix,
चुकी है।
a
हाँ
2 by 2 filter size with a stride of 2, and max pooling.
ओके।
Hello everyone, welcome back to my channel called Robotics Workshop, and today in this workshop I will talk about the pooling method, which is the second most important step in order to implement the convolutional neural networks. And I will talk about this method in detail, like what is pooling and why we need pooling in the convolutional neural networks, and we will also see about different type of pooling methods, and we will see when and which type of pooling method we need, and we will also see how we can implement each type of pooling methods, and I will also show you the Python implementation of each type of pooling method. So in order to learn everything, and make sure you don't miss any points during this lecture, so watch this video until end. And the last thing, if you are new on my channel, on this channel I usually make videos related to the real life robotics and about the control methods, computer vision, machine learning, and deep learning. So in order to join my crew, please subscribe my channel and also press the bell icon to get updates of the new uploads. So here we go. So here is the block diagram for the convolution neural network. So the first thing is our input image here, is which is of size n cross n, and we need this image in the matrix form. After that we need to apply the convolution on this image, and after the convolution we need to apply the pooling on the convoluted image. And I already talked about this convolution.
तो अपना कन्वोल्यूटेड इमेज पे पोलिंग अप्लाई हो रही है ना, अपनी जो एक्सपेरिमेंट रन कर रहे हैं हम?
नहीं भाई, कन्वोल्यूटेड इमेज में पोलिंग अप्लाई नहीं हो रही है, वो कॉन्सेप्ट सेम है बस।
अच्छा,
वो जो वो पूलिंग का जो कॉन्सेप्ट है ना वो सेम है, कॉन्वोल्यूशन पे कुछ पूलिंग अप्लाई नहीं हो रही है, वो समझाने का तरीका था उसका।
तेरा फेस टाइम का म्यूट कर ले बस माइक, तेरी दो बार आवाज आ रही है। अब बोल।
मैं बोल रहा हूँ कि वो जो प्रोसीजर थी वो सिर्फ समझाने के लिए थी पूलिंग कैसे होती है, बट उसके अंदर कॉन्वोल्यूशन नहीं हो रहा है, उसके अंदर फ्रेम्स पे नॉर्मलाइजेशन हो रहा है भाई, फ्रेम्स पे पूलिंग हो रही है।
आई सी।
उसमें पिक्सल से पूलिंग होती है कॉन्वोल्यूशन में।
method in detail in my old video with the Python implementation. So if you want to learn about this video, I will put the link in the description for this video. So go there and watch about this convolution method. And today I'm going to just talk about this pooling method here in detail. And but after the pooling method, we also need to apply the activation function, dropout function, and softmax function to get the classified outputs in the end. So we will see first what is pooling and why we need pooling. So pooling is actually reducing the feature map from high dimension to low dimension. For example, here is our feature map, which is of size 224 cross 224 cross 64. This is the height, width.
चलो ठीक है, ये तो समझ आ गया पोलिंग।
Suppose I give you two different lists of numbers, or maybe two different functions, and I ask you to think of all the ways you might combine those two lists to get a new list of numbers, or combine the two functions to get a new function. Maybe one simple way that comes to mind is to simply add them together term by term. Likewise, with the functions, you can add all the corresponding outputs. In a similar vein, you could also multiply the two lists term by term and do the same thing with the functions. But there's another kind of combination just as fundamental as both of those, but a lot less commonly discussed, known as a convolution. But unlike the previous two cases, it's not something that's merely inherited from an operation you can do to numbers. It's something genuinely new for the context of lists of numbers or combining functions. They show up all over the place. They are ubiquitous in image processing. It's a core construct in the theory of probability. They're used a lot in solving differential equations, and one context where you've almost certainly seen it, if not by this name, is multiplying two polynomials together. As someone in the business of visual explanations, this is an especially great topic, because the formulaic definition, in isolation and without context, can look kind of intimidating. But if we take the time to really unpack what it's saying, and before that, actually motivate why you would want something like this, it's an incredibly beautiful operation. And I have to admit, I actually learned a little something while putting together the visuals for this project. In the case of convolving two different functions, I was trying to think of different ways you might picture what that could mean. And with one of them, I had a little bit of an aha moment for why it is that normal distributions play the role that they do in probability, why it's such a natural shape for a function. But I'm getting ahead of myself, there's a lot of setup for that one. In this video, our primary focus is just going to be on the discrete case, and in particular building up to a very unexpected but very clever algorithm for computing these. And I'll pull out the discussion for the continuous case into a second part. It's very tempting to open up with the image processing examples since they're visually the most intriguing, but there are a couple bits of finickiness that make the image processing case less representative of convolutions overall. So instead, let's kick things off with probability. And in particular, one of the simplest examples that I'm sure everyone here has thought about at some point in their life, which is rolling a pair of dice and figuring out the chances of seeing various different sums. And you might say, not a problem, not a problem. Each of your two dice has 6 different possible outcomes, which gives us a total of 36 distinct possible pairs of outcomes. And if we just look through them all, we can count up how many pairs have a given sum. And arranging all the pairs in a grid like this, one pretty nice thing is that all of the pairs that have a constant sum are visible along one of these different diagonals. So simply counting how many exist on each of those diagonals will tell you how likely you are to see a particular sum. And I'd say, very good, but can you think of any other ways that you might visualize the same question? Other images that can come to mind to think of all the distinct pairs that have a given sum? And maybe one of you raises your hand and says, yeah, I've got one. Let's say you picture these two different sets of possibilities, each in a row, but you flip around that second row. That way, all of the different pairs, which add up to 7, line up vertically like this. And if we slide that bottom row all the way to the right, then the unique pair that adds up to 2, the snake eyes, are the only ones that align. And if I schlunk that over one unit to the right, the pairs which align are the 2 different pairs that add up to 3. And in general, different offset values of this lower array, which remember I had to flip around first, reveal all the distinct pairs that have a given sum. As far as probability questions go, this still isn't especially interesting because all we're doing is counting how many outcomes there are in each of these categories. But that is with the implicit assumption that there's an equal chance for each of these faces to come up. But what if I told you I have a special set of dice that's not uniform? Maybe the blue die has its own set of numbers describing the probabilities for each face coming up, and the red die has its own unique, distinct set of numbers. In that case, if you wanted to figure out, say, the probability of seeing a 2, you would multiply the probability that the blue die is a 1 times the probability that the red die is a 1. And for the chances of seeing a 3...
चलिए तो देख लूंगा मैं इसका तो पता है और इसका
अरे बट कॉन्वोल्यूशन पढ़ क्यों रहे अपन?
मैं बस वो समझना चाह रहा था कि उससे रिलेटेड ही रहता है पूलिंग लाइक आगे, तो मैं बस उसको एक बार समझना चाह रहा था. कॉन्वोल्यूशन पढ़ा हुआ है मैंने भी बट मेरे को याद नहीं है. मैं कब से तो कुछ देखा नहीं है मशीन लर्निंग का 2 साल से, तो मैं बस याद करना चाह रहा था.
मेरे पास में वही बेसिकली पूछ रहा था कि क्योंकि वो उससे वो है नहीं रिलेटेड, बट ठीक है.
ये आजा. तो डिजिटल ट्विन्स आर बोर्न बाय इंटीग्रेटिंग, ये तो पढ़ लिया था. यूजिंग सिम रेडी एसेट्स एंड रिमोट मॉनिटरिंग कंट्रोल ऑपरेशंस, इंटरनेट ऑफ थिंग्स सेंसर्स एंड डिवाइसेस प्ले अ क्रूशियल रोल इन प्रोवाइडिंग रियल टाइम डेटा that keeps real-time data that keeps digital twins accurate and up-to-date, allowing for dynamic interactions between physical and digital realms. Evolution of digital twins, NASA widely pioneering blah blah blah. During NASA utilized Earth-based simulators connected to spacecraft via real-time data updates, which allowed engineers to troubleshoot alongside astronauts. अच्छा देखा ये पढ़ा कि जो अपोलो 13 में स्पेसक्राफ्ट था उसमें वो सिमुलेशन कर रहे थे अर्थ पे इंजीनियर्स के लिए। तो वो इंजीनियर्स जो अर्थ पे थे वो प्रॉब्लम सॉल्व कर रहे थे वो ऊपर जो स्पेसक्राफ्ट में हो रही थी सिमुलेशन के थ्रू। Concept of digital twin has been applied in industrial blah blah blah. Recent now permitting interoperability by open data frameworks like वो ये तो ठीक है। Okay. Okay. ठीक है। बकवास। कोई काम का नहीं है ये तो।
What skills are needed to develop digital twin?
Okay, developers, 3D experts, and technologists with following skills. Developers experience with Python, React, and UI UX design. 3D expert experience with CAD, BIM, OpenUSD materials, lighting, physics, and animation. Technologists experience with IT, OT systems, integration, data center networking, AI, machine learning, DevOps, and data architecture. ये देखो तीन चीजें चाहिए एक चीज के लिए। These core teams are often supported by system integrators and software development and delivery partners like Accenture, SoftServe, T-Systems. Explore the digital twin learning part to get started with essential foundations in developing OpenUSD digital twin application and workflows for era of physical AI. Okay.
And so on.
The age of physical AI.
Optimized layouts, configuration and equipment placement, significant blah blah blah. ह्यूस्टन में है भैंचो दिए। अबे यार ले दे के गांव में जाके बनाई इनने फैक्ट्री.
भोसड़ी की फैक्ट्री गांव में बनती है.
You are on stream. Please maintain decorum.
तो चूत के गाली गलत तू कर रहा है उससे पहले.
Blur, please beep moderators.
There are no fucking moderators over here.
आज शॉर्ट्स जनरेट कराता हूँ और अपनी लाइव स्ट्रीम डाल के उसमें से शॉर्ट्स जनरेट कराता हूँ. उसको प्राइवेट रखूंगा अपने के लिए.
कोई आइडिया चोरी कर सकता है.
ओके चलो ये तो जाने दो. पढ़ते जा भाई ये.
Autonomous machines such as self-driving cars and warehouse robots requires vast amount of sensor data to be adequately trained and prepared for the environments in which they operate. Digital twins are the birthplace of these physical AI systems. They provide a solution to the data gap that artificial intelligence developers often experience, as they can be used as a safe sandbox to generate synthetic data and train, test, and validate AI models.
पढ़ना भोसड़ी के आगे. तू भी पढ़ेगा अब मैं सुनूंगा.
Amazon Robotics, for example, uses digital twins of a warehouse to simulate and optimize warehouse design and flow. The company uses these environments to generate large photorealistic synthetic data sets to accelerate training, improve accuracy of computer vision models, and improve overall productivity. When models are deployed to the real world, the warehouse robots can detect objects more efficiently and navigate the facilities. The Kion Group is leveraging an Nvidia Omniverse blueprint for testing multi-robot fleets to train its robotic agents, including intelligent cameras, forklifts, and robotic equipment. Leveraging mega क्या है?
ये मेगा. This demo experience allows you to configure autonomous mobile robots, AMRs, and simulate their movements in the warehouse environment. You can view examples to view pre-cached simulations or modify the preset configuration by following these steps. In each AMR, you can configure the type of brain control logic, camera sensing capability, render type visual representation. Step 2A, choose a start or end point for AMR's path, modify path mission. Okay. Step 2B, modify paths missions, then select new point from available options shown. Once satisfied with your modifications, run simulation. Note some simulations can take time to generate. ये देख यही बोल रहा था मैं. वो जो तेरे को मैं दिखाना चाह रहा था यही है वो. टेस्ट मल्टी रोबोट फ्लीट्स फॉर इंडस्ट्रियल ऑटोमेशन. तो जो ऑमनिवर्स करेगा ना, अरे यार ने वो कर रखा है बहन. अरे यार ये मैं यूज कर पा रहा था ये पहले. ये अरे आ गया. अरे यार इनने इस पे ना तू वो जो मैं दिखा रहा था ना, थ्री डी वेयर हाउस वगैरह में तू कर सकता था वो. इनने वो बंद कर दिया है यार वो. हाँ ये है शायद चल रहा है ये वाला. पढ़ना है.
वो दिख नहीं रहा.
हम्म.
Building AI factory is monumental challenge requiring intensive planning and cross-discipline orchestration to ensure that these complex facilities can be built safely without waste and with optimal use of power and cooling. This type of multidiscipline aggregation and simulation is accelerated with Nvidia Omniverse libraries and SDKs as well as OpenUSD. Huh. नीचे कर क्या है
What if scenario, space planning, and operational dashboards in real time.
हाँ हाँ वॉक थ्रू मेरे को देखने दे एक बार वॉक थ्रू में क्या है
NVIDIA's Omniverse DSX blueprint is the digital twin manifestation of DSX reference design, demonstrating to developers how to use Omniverse libraries to design simulation and operation across AI factories. Experience walkthrough.
The application opens to an interactive global viewport. Users will see a configurator panel in the top right hand corner and a left side toolbar organized into AI main view section. Clicking a side reveals analytics panel which shows detailed site information and performance KPI. Selecting the simulation in the icon left toolbar launches the simulation bar and changes the view to a predefined camera from here.
मेको हाँ चल पढ़ ले.
Users can show between thermal or electrical simulation. Click Begin Test and initiate the simulation. I see.
एक सेकंड कहाँ लिखा है ये? The application opens the interactive global viewport. Users will see configurator panel in the outer left side toolbar organized into AI main and view sections. Clicking a side reveals the analytics panel, which shows detailed site information and performance KPIs. Selecting the simulation icon in the left toolbar launches the simulation panel and changes the view to predefined camera. From here, users can choose between a thermal or electrical simulation. Okay. पढ़ नीचे पढ़. During the simulations.
During the simulation, a color or motion overlay will appear on the 3D assets in the viewport. The camera option in the left toolbar allows user to adjust the viewing angle. अरे dude ये तो वो है पूरा उसका जो टूल है उसका बता रहा है वो अब जब बिना टूल देखे थोड़ी वो देख सकते कुछ
ये पढ़ना to begin.
अरे तो मैं पढ़ के करूंगा क्या भाई पहले वो अपने को टूल देखना पड़ेगा ना भाई उसके बाद ही तो
ये है टूल वो.
तो कर
इसको यूज कैसे करते हैं वो पता नहीं है.
वही तो देखना
हाँ ये रहा.
ओ माँ चू
भाई डेकोरम स्ट्रीम पे है भाई.
crazy motherfucker
हॉट लोड सिमुलेट करने के लिए ये है.
this is what that documentation was talking about.
इलेक्ट्रिकल के लिए ये है सिमुलेशन. लोड में इसको सिलेक्ट. अच्छा ये बस.
But I think it's not simulating at all.
स्टार्ट बिगिन टेस्ट. हाँ अब हुआ ना टेस्ट बिगिन. अब कर रहा है वो सिमुलेट. ओवरलोडेड स्टेटस ओवरलोडेड. पार्शियल फेलियर ओवरलोडेड. ये देख रहा है. और क्या है. स्टॉप टेस्ट थर्मल बिगिन टेस्ट.
Load.
अच्छा ये जो चीजें यहाँ पे ऑरेंज वो दिखा रहा है शायद. कुछ तो हुआ था अभी. एजेंट.
AI factory data center configurator.
शो द साइट फ्रॉम टॉप. सेशन टाइम रिमेनिंग 7 मिनट. 7 मिनट्स के लिए हमने बस. स्वीडन साइट. हाँ तो ये साइट पे पहुंच क्यों नहीं रहा है ये. ओ ये है देख,
हम्म।
वो पीओ व्यू वाले प्रोजेक्ट में मैं ये करना चाह रहा था कि ये दिखा दे तुमको।
आई सी।
बट इसमें सिमुलेशंस और ये क्या है, डेटा हॉल रो, रैक्स क्लोजअप, हॉट आयल कूलिंग, कैंपस एरियल, सिमुलेट करने के लिए सब कुछ है। भाई यही है फ्यूचर, मैं बोल रहा हूँ।
ठीक है ना।
Omniverse DSX blueprint for AI factories. AI factories का भी अलग से किट है इसमें, और ये ब्लूप्रिंट कार्ड है इसमें। अब देखते हैं इसमें, ये रहा है आर्किटेक्चर डायग्राम, देखो अंदर बादशाह।
का जूम sim ready, open with geometry validation sim ready. At the end, eventually everything comes down to the open USD subscription, sorry, certification.
Hmm.
So certification तो करने ही पड़ेगी।
बड़े परप्लेक्सिटी से करवा ले क्या सर्टिफिकेशन वो वाला भी।
It is inevitable. Certification is the must key because we can see that we are using open USG geometry that also uses geometry validation, and then it goes into the sim ready geometry, then into the asset validation, and then it outputs some sim ready AI factory open USD asset.
Asset.
Asset. Asset.
Okay.
Then we also have, like, as we can see over here, we have electrical metadata, thermal cooling metadata, connection points data, and I think all of these are some kind of validation or config files that we already have in our sim ready specification. And we are, like, I think collecting everything into a single file and then pouring everything into the geometry file of the sim ready AI fact AI factory sim ready metadata. I see. What is this? We also have app streaming API, AIFDT, AI agent. Dude, this is some complex shit over here. The only thing I was able to understand was the SimReady thing. I don't know what the hell is this.
Hmm. Obviously, bro. Okay, here it is. What's included in the blueprint? Nvidia's Omniverse DSX blueprint repo contains digital twin geometric based on entire DSX reference designed for 50-acre site, including computing, building, support infrastructure, front-end web application with user interface developed with Omniverse libraries for interacting with digital twin, viewing simulations, and creating and saving build configurations. Simulation-ready assets to accelerate digital twin creations, computational fluid, dynamic thermal hot aisle simulation, sample compute configurations for DSX such as GB200 and GB3300. Okay, it is powered by Nvidia libraries such as CUDA, Omniverse Kit, WOM, WOP, AI Agent, NIM, RTX, Kit, CAE. Bro, focus over here, motherfucker.
I'm listening, bro. I'm all ears.
I'm gonna put you on screen now.
Shoot me.
Stop looking in your
I'm
bitch
doing
ass.
multitasking, dude. I'm doing multitasking. I'm using Cloud Code as well.
You're on screen. Read this sheet.
What key functionalities include accelerated time to revenue, streamlined operations through system level optimization, energy efficient performance, maximize token throughput per power budget while security, early access to power resources, sustainable resource management, minimize environmental impact using drag pooling CTUs, intelligent workload placement, AI driven reliability, future proof infrastructure, coordinate IT and OT systems to automate workload distribution based on time, power, and cooling availability. Hmm. The Nvidia Omniverse DSS Blueprint provides an end-to-end framework to build, simulate, and optimize gigawatt scale AI data centers, seamless transition from custom app development, physical, accurate design to high efficiency, grid resilient operations. Give me
That was a little bit about the Omniverse blueprint.
Yeah, I think that's how the future is gonna be. Are we already in the future? What do you think, Shaurya?
You're already in future. इसमें और भी हैं. Build your own transaction foundational model by using transformer architecture on tabular data. Weights biases. Nvidia. Yeah.
Dude, this is what we are trying to do in our experiments, right?
In what?
Experiment training with the models.
This one, build your own transactional model. ऐसा.
Yeah. Training pipeline. We are what they're putting is zoom into the architecture.
One second. Transaction foundational models are large-scale AI systems designed to understand, process, optimize payment transaction-related data across domains like transaction authorization. अबे नहीं बे, ये कुछ और है.
Hmm.
कुछ और है, वो नहीं है.
Hmm.
Data, historical transactions, NVIDIA Rapids data processing, inference pipeline, current transaction, NVIDIA Rapids tokenization, foundational model, NeMo pre-trained model, extract embeddings. अबे ये तो वो है यार, ये तो कुछ और है, ये तो है ही नहीं उसमें. फिजिकल एआई का से रिलेटेड नहीं है
दोनों
ये.
होगा ना.
नहीं, ये फिजिकल एआई से रिलेटेड ही नहीं है, वो कुछ और है ये.
Oh.
ये बैंकिंग और फ्रॉड अलर्ट वगैरह वाले, वो नीमो ट्रांजैक्ट वो नहीं देख रहे थे अपन, प्री ट्रेन्ड मॉडल
Huh.
कि खुद का फाउंडेशनल मॉडल कैसे बना सकते हैं.
Hmm.
वो है ये.
Hmm. Sure. Sure. So what else do we have now to focus on?
Main thing we were focusing on was
The blueprint thing. I guess.
Yeah, but all of that will come later, bro. Like after we move on from our coverage gap analysis. First, we need to understand what's the failure and all that shit. And we need to like start building out this shit.
Hmm.
Where is it? ISAXim. Hmm. तो इतने ज्यादा टैब खुल चुके हैं ना कि मेरे को टैब वो रखना समझ नहीं आ रहा. Welcome to physical AI learning. This is important, bro.
Which one?
Physical AI learning. Over here,
Building autonomous robots. Start learning. Click on the start learning thing. Let's see what does the first.
we
Oh,
can
dude. Oh,
choose. We
this is
can
the
choose.
app launch template, dude. This was the same thing that we're trying to do earlier.
No, that was OpenUSD. This is
No, no.
different.
I also worked on this. I did take a look into the kit app development toolkit as well. But then we were like, okay, no, we have to first focus on OpenUSD.
Okay, so we can do one thing.
Hmm.
We can do these courses first.
Hmm.
Learning paths. This is the perfect thing for us. This is like
Hmm.
6 to 10 hours intermediate.
Hmm.
6 to 10, 3 to 4 hours
Hmm.
OpenUSD. Getting started with Isaac Sim 2 to 3 hours.
Hmm.
Bro, this is what you were looking for, right? Like this will teach
Yeah.
us everything about. Oh, what is this
What?
massage?
No, it's not massage. I think it's
I know, bro. It's
surgery.
surgery.
Hmm.
चूतिए मेरे को मालूम है जोक मार रहा था.
Sometimes people can be dumb. All right, so we have something for tomorrow then.
We will be running those experiments parallelly and doing this.
Yeah, we'll be running those experiments parallelly, definitely in the morning.
Yeah, just start those. We have a green light for those experiment modifications that we have. So
All
just,
right then.
but can you check right now because it's 12, so your limit might be reset.
Ugh,
Please, please, let's push a little bit.
Arre dude.
Bro, this is the moment we make the difference.
This is
Some.
not the moment we make the
Listen,
difference.
listen,
I can
listen.
do it in the morning as well. All right. This is not the word. I'm not gonna push it right now. I'm gonna
Bro,
do it in the
imagine
morning.
like two other guys are trying to do
No,
the
no,
same
don't
thing.
don't imagine.
And those guys are is thinking like us. Okay, we're gonna do it tomorrow morning. But
Both of us will have the same conclusion. None rather than that. I don't give a shit.
Hey,
Don't
bro.
push it. Don't push it. I already
Bro,
know
if
tomorrow.
we can, those guys are thinking that they're gonna do it tomorrow, but this is the moment we
I'm
do
also
make the
thinking that
difference.
I'm gonna do it tomorrow. Let's check out
But
tomorrow.
this is the moment, bro, we make the difference. We gotta do it right now.
I gave you a template
Everything.
pooling. You can do it in your Termius app as well. Do it. Mm.
Okay, let's see what this is. Okay, start learning. Learn OpenUSD, how to contribute, how to get certified, why get certified, developer resources, what is OpenUSD. Oh, we have this in our Git, right?
Mm-hmm.
In the thing. Okay. So that is fine. Getting certified ISAC for healthcare. Okay, look at this.
Mm-hmm.
Five core areas: robot construction and control using OmniGraph ROS2, integration URDA, facet importation and physics configuration, synthetic data generation with replicator for AI perception model training, software in the loop, workflows for testing robotic software in simulation and hardware in the loop, methodologies for deploying applications on Nvidia Jetson hardware.
Getting started. Where is the ISXM, brother?
Huh?
Where is the ISXM?
ISAXM, bro. We ran ISAXM on Linux the other day. That's the way
I don't
we.
remember it, bro. I have to
Abe,
remember it, bhai.
what the fuck, bro? We rented the GPU from Vast AI and we ran a Linux machine and we started ISAXM over there. So I think that's our next goal for tomorrow.
Oh, I see.
We already have a little bit of. I'll okay. What I'll do is I'll come prepared with a little bit of OpenUSD stuff.
Mm-hmm.
Like I'll work on that because I already have the repo that you created
Mm-hmm.
called on OpenUSD.
Mm-hmm.
So I'll read that more, and then when we'll do the stream tomorrow,
Mm-hmm.
we'll stream this. We'll do the vast AI thing. We'll rent
Mm-hmm.
the GPU
Mm-hmm.
and we'll run Linux, and then we'll
Mm-hmm.
start ISAXM over there. I think we already have the shell script for Claude to run,
Yeah, yeah, we do have the shell script for that. Don't worry.
so it should not be an issue. Okay, through these modules, you'll work with sensors including RGB, cameras, 2D LiDAR, IMU systems, implement differential controllers, articulation systems, apply domain randomization techniques for dataset creation. Bro, you know what this will help us do?
Mm.
This will basically get, like if we are gonna do all this on stream and we are able to create the robot and
Mm-hmm.
get it to simulate stuff,
Mm-hmm.
we have solid proof that we can do it.
Mm-hmm.
This will help us in getting a job later if we want to do a job first.
Mm-hmm.
If we don't get funding.
Mm-hmm.
Oh, there is one viewer. Hello. Hi. So I think overall this was like a good,
Mm-hmm.
productive stream.
Yes, I think we have something for tomorrow.
Yeah. Now we should focus on this workflow guide that we have.
Mm-hmm.
Physical AI learning. This is very important now. I think we need to do this anyhow. Okay, this is the certification.
Yes, this is the certification that I was talking about. Certification is really important because the industry requires the certification to be as a necessity to get into the job market.
Okay, wait. Read this.
Mm. Okay.
So
So
we'll basically need to complete the study guide over
ये तो
here.
थोड़ा सा
Yeah. It's going to be tough, but we can do it.
it's not gonna be that tough. I would guess like open user certification won't be that tough, but
Uh,
the exam will be tough for the
okay.
questions.
Oh,
Prove
okay.
it in itself.
Oh.
Buddha just once said, if you're trying to build a company, you need to work really hard. Like 100 hours. And if you think sure as your open user certification is tough, then you have already lost.
Why don't you already have that certification then? Bitch.
You know, you know
You
why?
know.
Small steps. Small steps. What the fuck are you doing?
I'm just trying to see what's the thing.
What the heck is this 30 verse?
This is where the test will happen.
Are you trying to hack it already?
I'm not trying to hack it, bro. I'm just
Please
seeing
don't,
what's
please
the
don't.
procedure. You have no examination reservations at this moment. Certificate. ਹੁਣ ਤੇ ਰੋਜ਼ ਤੈਨੂੰ ਜਾਣਦੇ I think that's enough for today's stream. I think we hit 1 hour.
We have Open UAC certification. Bonus for attendees receive a 50% exam discount. Wait. Dude, it's on April 30.
Oh,
Dude, it says like if we can this webinar, if you attend it, we can get 50%
but
off.
where is the webinar?
Dude, it's
Register now.
online. Piece of shit. Register
Ro-
now. Register it now.
What is this? What? Select events.
Hmm.
Thursday, 9 a.m., April 30. 9 a.m. PT. What is PT?
Pacific time. Beach.
So like 12 a.m. over here, EST.
No, no, dude, we will be already ahead, right?
Yeah, that's what I'm saying. 12 a.m.
12 a.m.
PST.
How would it be 12 a.m.
3 hours.
Pacific
Pacific time
time?
is 3 hours
12
behind
a.m. It would be 12 a.m.
12 p.m. Sorry. Or
What is it?
12 p.m. 12 p.m. Yeah, 12 p.m.
12:30 to be precise.
अबे चूतिए 12:30 यहाँ पे ये इसका बोल रहा है ये पैसिफिक
1
टाइम.
p.m. BRT. BRT. What is BRT?
Let's check. 3 hours ahead. अबे वही है भोसड़ी के सही बोल रहा था.
What is BRT? But
Brasilia time पता नहीं Eastern Standard Time 2 hours ahead of whatever that is. But let me register. How I don't know what.
we are just registering to get that 50% coupon code.
Where okay. Business email address. We don't have a business organization. InstruX. The huh? There is no tech. What?
We're going to do HPC or scientific computing or something. Cool.
CEO. Bro, what the?
Submit it, bro. Submit it.
I think you should do it too.
Bet. Bet. Ah,
Here you go. I sent you the link. What to expect? Get an overview of 2026 certification lineup, including new exams for accelerated data science, OpenUSD, and physical AI. Understand role-based certifications pathway so you can choose the right exam for your career and your team. View the demo of hands-on component of professional exams launching at GTC. Learn practical exam prep strategies. Sample question, bro. I think we should complete our OpenUSD stuff, and before that,
before what?
before this webinar.
But I have already watched a lot of videos from Nvidia, the Omniverse.
Bro, you are God. You are God level, bro.
I would disagree, dude. That's
Fuck you. बहनचोद सारी चीजें तू पहले ही कर लेता है बहनचोद कैसे तो पता नहीं बट वो यूज नहीं हो पाती है बस
yes, that's a different problem. मैं क्या करूँ इसमें?
शूट साला
आलस.
okay Gary Fluid technical certification manager Marco Alves Christina Glanville and Asha Hedges Thursday Friday छुट्टी ले लूंगा मैं
ले लो. Corey is listening, you know. Corey.
I don't think he is
Hey, bro, so you're gonna take Thursday and Friday leave, right? Yeah. Corey.
I wish he's not doesn't
वो पूछेगा तुझसे. Sure, you're my man. Oh.
let me end my stream first कर दी मैंने end. देख के गया कोई एक बड़ा और मेरे को पता नहीं ऐसा क्यों लग रहा वही होगा